I am the Tamil Nadu Weatherman.
When Chennai flooded in 2015, amid the panic, a Facebook page went viral. It was a page called the Tamil Nadu Weatherman, and it made localized predictions for rainfall in Tamil Nadu with astonishing accuracy, and was run by an unassuming engineer, Pradeep John. Over the course of November and December, the page warned often of heavy rainfall. Pradeep was proven right, which made him a kind of cult figure. Welcome to Water from the Indian Express, a series that explores water in all the ways it enters our lives. Last week we talked about how the monsoon is important to India, not just as a resource or a factor in our economy, but also in history, art and culture. Today we're going to look at measuring and tracking the monsoon. Pradeep John was 12 years old when he saw his first cyclone in Chennai, then called Madras.
Yeah, 1994 cyclone played a huge role in my interest because I was a kid who started seeing this howling sound cyclone crossing Chennai in 1994. Subsequently, in 1996, I also witnessed a huge flood. Those days, it did rain for maybe 3 to 4 days continuously in the month of June because of a cyclone storm. So those days we did not have power or internet or something like that. So the only thing I did was watch rain, float the rain.
Watching the rain became tracking the rain, and Pradeep began looking at and collecting data on rainfall regularly, just for fun, until it became something more.
Hobby, I think for the past 20 years I've been collecting rainfall data from various sources. Mostly I love places with extreme rain. So those days we did not have any internet, so we used to rely on the news channel and also the Hindu newspaper. Once the internet came in, we started searching from without already weather has been predicted. From 2008, we all started working. We formed a group of people. We thought there are like-minded people like us also who are interested in weather. So we just started sharing of mutual information. Some people are specialization in cyclones, clouds. Some people go only hot days. There are so much within the area of weather itself. So we started getting mutual information sharing. So what works in our area, what doesn't work, how the wind has to be. So all these things we learned in a mutual manner.
Given how hard it is to predict the weather, I asked Pradeep how he did it.
Thunderstorms or daily rains are a little bit complex, hit and miss kind of thing. During monsoon rains, most probably we can say that in a day or two before, we can say this place is going to get rain. Maybe heavy rains or moderate rain. And the seasonal thing, say one month ago or 15 days ago, we can say that the trend, the coastal areas are going to be getting good rain, the interior are going to get good rain, the western ghats are going to get rain. So kind of in 10 days, 15 days lead also we can say. Even monthly we can say, but the accuracy level as the day goes on. So if it is 2 or 3 days, 2 days means I can say it as 95%, 90 to 95% accuracy. In 1 day or in half a day, I can say maybe 99% accuracy. As the day goes on, the accuracy level reduces. Weather is predicted based on the numerical weather prediction all over the world. At the same time, throughout the world, the model runs are, it's not for India-specific run or regional run. So world over, the runs are carried out. We come to know which will work, which is staying correctly. So by experience, by watching, okay, this is a wind pattern. So today, it seems it is getting it right. Because often they predict rain, but the rain will not happen. So based on the experience, we will say local conditions, okay, there is a good chance of rain today, there is no chance of rain, something like that. So the local condition, you must be aware of the local condition and know how much it will rain.
Pradeep uses lots of publicly available data to make his predictions. But where does this data come from? How is it collected? I set out to find out. But first, I had to answer a bigger question. What exactly is the monsoon? In the course of what I like to call my great monsoon quest, I reached out to the Indian Institute of Tropical Meteorology in Pune and spoke to a scientist there.
I am Rocky Matthew Cole. I work at the Indian Institute of Tropical Meteorology in Pune. institute under the Ministry of Earth Sciences. We have about 150 scientists working on the monsoon here at the Indian Institute of Tropical Meteorology. I have been working on the changes in the monsoon pattern over the past century and how the land, the ocean, and the atmosphere work together to create these changes, and how climate change is impacting the heat distribution and changing the monsoon.
Roxy explained the mechanism of the monsoon and why it happens.
Monsoon is basically driven by the heat and pressure distribution during the season. So during northern summer, that is during June to September, the Indian subcontinent gets warmer than the Indian Ocean. So consequently, the air over the land, we call it the troposphere, the lower column of the atmosphere, we call it the troposphere. That also gets warm, and a region of low pressure forms over the land. So basically, this drives the wind and the clouds, which forms over the ocean towards the land, and this results in those huge amount of rainfall which occurs during the monsoon season.
Okay, for the monsoon to happen, the temperature above the land goes up, and then the pressure goes down, which makes the clouds over the ocean move inwards. And how do you measure this? The story of measuring India's monsoon rain goes all the way back to 1875 and the foundation of the Indian Meteorological Department, or the IMD.
I'm Soumya Ashok. I cover environment and water resources for the Indian Express.
You remember Soumya from the last episode. Soumya went to the Ministry of Earth Sciences to talk to the Secretary M. Rajivan about the monsoon and the IMD.
And if you step back a bit and talk about the Met Department itself, so what is the history of the IMD?
History means, in 1880, early 1870s, there were a lot of droughts in the country. At that time, British government was ruling our country, so they took a decision to establish this IMD, Indian Meteorology Department. So it was established in 1875 to give forecast for different for specific droughts, tropical cyclones. And before this, meteorological observation started even in 17th century, 18th century. The first observatory was in Chennai, the first meteorological observatory. So established by British people in Chennai. Still that observatory still exists in Chennai. And so IMD was set up in 1875, but immediately after it was set up, we had severe drought, we had severe tropical cyclone, many people were killed. Okay, so that was the humble beginning we had, and then we progressed further, and we had developed our own observation system. And initially it started with the tens of observatories, and now we have hundreds of observatories now. In the atmosphere, the climate system, we cannot go and measure everywhere. So it's very difficult. And so these models gave you a lot of insights to understand how the atmosphere behaves, how the climate system behaves, along with the observations, of course. And second thing I want to highlight is the use of satellites. So that has really revolutionized the weather prediction. If we did not have satellites, the skill at present what we have, we would not have achieved it. And that has really, for example, if 100 data, we, as you know, that all this data go into the weather prediction models too. Then they objectively analyze it and use it for further prediction. And out of 100 data goes into the model, 90 data comes from satellites. So that's a kind of role.
So what was that turning point in India when we relied more on satellites? Which year was that when we
So that's in the 70s, and we had INSAT and all these things, 70s, 80s. And for some, but before that, we used to get the data from NOAA satellites. So that's from US. That was a polar orbiting satellite.
Okay.
So north to south, and so we don't get any kind of a permanent observing system like geostationary, like INSAT. So it sees the same place continuously. But polar means it comes from north and south. It just passes some region, and again it comes after some few hours. So that kind of observations. So now we have plenty of satellites, both from our side as well as from foreign satellites. So we make use of all the satellite data. It is all data shared just for the purpose of weather predictions, and we make use of that.
Satellites are really important to collecting a lot of data. But what about the actual rain? How do we know how much rain has fallen?
We did an interesting calculation for the summer monsoon rainfall based on the amount of rainfall received. If you see, during June to September, India receives about 900 millimeter of rain per square meter. So 900 millimeter of rain per square meter is roughly equivalent to 900 liters per square meter. And if you consider the total area of India, 3 trillion square meters, this would mean that India receives roughly 2,700 trillion liters of water. So to simplify, that is about 200 lakh crore buckets of water, normal buckets, where one bucket will be roughly 10 liters of water. That is 200 lakh crore buckets of water is received during that season in the country. But we have water problem. Almost half of it goes to the rivers, of course, and a lot of it gets evaporated as well. But with clear water management strategies, we can save a lot of this water and can utilize it for the better of us.
That's Roxy Cole from the IITM again. Roxy explained many things to me over the course of not one but 2 interviews. He told me about the monsoon and predicting it, and how rainfall is changing. He also was a fount of information on how we measure and track the rain.
During the last decades, we have automated most of these rain gauges which measure this rainfall. And now the Indian Met Department, that IMD, has about 1,300 automatic rain gauge stations which measure the hourly and daily rainfall. And some of these are equipped with temperature and humidity sensors also. So the automatic rain gauge station means the observations are made and transmitted automatically. And this data is transmitted to some ultra-high frequency transmitter and also through a satellite to the Earth Station facility at IMD Pune. And these rain gauge stations are used to measure and track the state and the progress of the monsoon at any time of the year.
But watching the monsoon involves a lot more than rain and rain gauges. There are the satellites that Mr. Rajivan mentioned. There are sensors installed on buoys that are scattered across the ocean. Sensors and buoys that need to be dropped off and occasionally repaired and retrieved. There's Doppler weather radar in most major cities in India, which is really kind of cool because it doesn't just sort of measure how much it's raining, it also measures the size of the drops of rain, which can actually give you a good sense of how intense the rain is. I mean, we all know the difference between tiny, fine little drops and those big, huge ones that go splat. There's also aircraft that study the clouds and cloud patterns. So this multi-channel investigation to find out more about the rain is not even new. As early as the 1960s, there were these big collaborative efforts where scientists would get into ships and go across the oceans throughout the rain season and collect all this data. Now, I love the rain myself, but I found it fascinating that there were these men and women who were so hooked on it that they spent their whole professional life chasing it. And clearly, they accumulate a vast amount of data on the monsoon. What happens to this data? Well, it goes into those weather models that Mr. Rajivan was talking about.
The science also progressed with a lot of observations and modeling, especially modeling. The modeling has really started in 1940s, 50s. And the models, the weather prediction models in 50s basically. And that have really given in more insights.
Roxy told me how and why the models work.
A lot of this information goes into the weather and climate models. We call them climate models, but these are like computer programs which represent the Earth system, the physics and the chemistry and the biology of the Earth system for the ocean, atmosphere, and the land. Using these computer models, we simulate the atmospheric conditions, which can fill in the gaps in the data because we cannot measure each and every nook of the Earth. These models fill in the gaps, and we can also use them to analyze and predict the weather and climate for the future.
So all these factors are tracked. All this data is collected and everything is plugged into the models to tell us when the monsoon will arrive, how much rain it will give us, and what we can expect from that year's monsoon. Only it rarely works out that way. The reality is that the monsoon is such a complex system that it is only just now that we're able to collect enough information about it and process that vast quantity of information. And now the weather patterns are changing.
If you really analyze the data for the last 50 years or 60 years, the mean rainfall is remained same. So there's not much change in the seasonal rainfall. For example, if you Old days we used to have 89 centimeter. Now also we get, of course, there's a lot of variation from year to year variations. But on a large time scale of 100 years, if you take, monsoon is stable. So that's a good news. Monsoon is a very robust system. It has not changed. That's a good system. But at the same time, we have changes occurring on the regional level. For example, Kerala is getting less and less rainfall every year. Chhattisgarh and that region, adjoining parts of Orissa, those regions again will be getting, we are getting again less and less rainfall. Whereas parts of Maharashtra, Rajasthan, they are getting more and more rainfall. So these are regional changes in the regional rainfall pattern. That's all happening, number one. Number two, this is I'm talking about mean rainfall, mean seasonal rainfall. So all India rainfall is not change. But if you calculate, if you really analyze the daily rainfall, the extreme rainfall events, there's a substantial increase in the extreme rainfall events which are happening. And number of days in which it rains also reduced. So now instead of 25-30 days of rains, we get only 15 or 16 days. And I said the mean is same. That means when it rains more heavily.
For some parts of central and north India, we see a consistent pattern in the changes in the monsoon. Specifically, there is a decline in rainfall in this region at about 1 millimeter per year. So this can be about 3 millimeter per year or more in some locations. And these changes have been recorded consistently since 1950s. That is almost 70 years now. Yeah. So a 1 to 3 millimeter per year change would mean 70 to 200 millimeter change in these regions for the entire period. So we need to remember that at many of these locations in central and north India, the agriculture is still largely rain-fed. So that much amount of decline in the total rainfall for the summer monsoon season can mean a lot in terms of agriculture, in terms of water resources for daily use and for other purposes.
That's right. The monsoon is changing. And in next week's episode, we're going to look at how it's changing and what that could mean for us in India. But for now, I'll leave you with Pradeep again, who sometimes doesn't sleep all week as he reassures people about the weather, but he does it only for love of the rain.
Whenever there is rain, we feel the joy inside. We feel the month of January to May month, mostly the dull month. So, but once you see the clouds building up and the rain falling, that joy inside you, it changes everything. So I forget all the other things happening around.